Welcome back to the channel. Today we will be solving magnitude easy version. You are given an array of length n and a starting variable c equal to 0. For each I from 1 to n, you need to perform exactly one operation out of the following. Either you add the value of ai to c, or you take the modulus of the value of c after adding it with a of I. So greedily, what comes to mind is after every iteration, if the value is in negative, we can make it positive, and that might give our maximum value of c. But that fails in certain cases, like -1, -2, -3. Here, if we don't take mod, then our final answer comes at -6. And now if we take mod, this becomes +6. But what if we had taken mod on every step? Then this would become 1 and -2 becomes -1. Modding it gives us 1. Then -3 gives us -2. Modding it gives us just 2. So this was a more optimal answer, and hence our previous greedy solution cannot work. Now what else we can think is, if there are some negative numbers together surrounded with some random positive numbers. So we can take the mod after calculating the value of all of these negative numbers. Like this would become 17, then 16, then 14, 11. Like wherever you come across negative values, the goal was key, instead of modding at every operation, we mod all of them together, because now here there was 8 and 9. But what if we had something like 1? So over here, modding it after all of these negative numbers would give us an better answer. But that also won't work in cases like, suppose you would have -1, -2, -3, and then a small number 1, and then some very big minus numbers. So, like, I'm not saying exactly this case. In cases similar to this, maybe modding all the negative numbers together may not work, because this number, even though it is positive, it is still very small. So over here also, not modding may give you a better answer. Now I'll show you a greedy solution that works for all cases. Let's say you have two possible answers. This is your minimum possible answer up to your ith number, and this is your maximum possible answer up to your ith index, and you are having some number x. So what will your cases become? -3 plus x, -3 plus x mod, 6 plus x, and 6 plus x mod. Now out of this, I will again choose only the minimum value and the maximum value. Min goes here and max goes here. And then at the end, I will take the mod of both the min and max and print the max out of those both. Now, why does this work? I'll show you. Now see, suppose you are solving this question using DP, and uh, at the ith state, you have some possible answers like -5, -1, 0, 2, 6. These are your possible answers till your ith state, and you are finding all the answers ahead of your ith state and checking which is maximum. Now I'm saying ki you will get your maximum answer from this or this. Whichever number is whichever number comes, no matter how positive or no matter how negative, it is. But if I choose -5 or -1, I will definitely get a more negative answer by -5, and I will definitely get a more positive answer by using 6 instead of 2. So from all of the possible answers you have up till your ith case, you will get your maximum answer by either the most negative number or the most positive number. Rest all states are useless. Okay, this is what I thought of. So implementation is quite simple. You find four answers, which are answer 1 and answer 2 plus a of y and modding a of y. Then answer 1 becomes max of all of these answers. Answer 2 becomes min of all of these answers. And so answer 2 will have my least negative number. Sorry, my least negative number, and answer 1 will have greatest positive number. So my theory is, for calculating the max answer, you will only need the least and maximum answers up to your ith case. Rest all cases you won't need. Okay, I will add this submission link in the description for your reference. Thank you guys for watching. Make sure to subscribe and like the video.